Okay, I'm going to share my screen and we're going to get started on our Unit 10, our final unit review, not our final review, but our final unit review. Make sure that you fill in your answers on your own sheet of paper so that you could take that home and you can study it tonight because you have a test tomorrow. The test will be open note, so please do not stress because I know this unit went by pretty quickly. So we will be going over your review. Okay, so remember that a force is a push or a pull that causes motion, and a force is measured in is a vector, so it's measured in both direction and magnitude. So we say which way the force is moving, and then we also say the amount of that force. And we first classify forces as either contact or non-contact forces. A contact force is a force caused by direct physical contact. So some examples include friction or applied force, or even spring force. So if two objects are actually touching, this means that they have direct contact, making them contact forces. So if you are a force that acts at a distance, so if a force is applied at a distance onto objects, this is what we call a non-contact force. And examples include gravity, electricity, or electrical, and magnetic. So these forces do not require touching, but they do and can still cause a push or a pull. So one of the non-contact forces is gravity. And gravity has two different relationships that that determines how strong that force is. So one is the mass. So for every item that has a mass, it also has a gravitational pull, which means that you yourself have a very small gravitational pull. That means any object that has a mass has a gravitational pull. A good example is the sun versus the moon. Both have a strong gravitational pull, but the sun's is a much larger and much stronger. That's why it has a lot of planets orbiting it, and the moon itself doesn't have other items orbiting it. So any item with a large mass has a large gravitational force. Anything with a smaller has a small. So the second thing that influences the amount of gravitational pull is the distance. So items that are closer together, so if they are not far apart, they have a very strong gravitational pull. So like if we're talking about space again, between Sun and Mercury, they have a very strong gravitational pull compared to Sun and Neptune. So the further apart something is, the smaller, I need to change that, the smaller the gravitational pull. So the stronger the gravitational pull, so the closer they are, the stronger. Further apart, the smaller. An unbalanced force means that, so I'm going to change that right now so that we do not forget. Hold on, or I'm just going to go and change this while we're on this page. The small. Okay, so do not make that mistake. The further apart they are, the smaller the gravitational pull. All right, so when forces act on each other, they can have either an unbalanced force reaction or a balanced force. An unbalanced force means that the net force is greater than zero. And since the net force is greater than zero, this means that motion is occurring. So either a push or a pull is occurring and causing that item to move. A balanced force means that the net force is zero, so the item is not in motion. So if the item is equal, if the forces are zero, so if you're playing tug of war and you're both pulling at 20 newtons in opposite directions, that means the net force is zero. So you do not have an actual movement of the rope. It doesn't mean that it can't change its physical properties. So remember, if an item is moving in a certain direction caused by a force, this means that there's an unbalanced force happening, meaning that the net force is greater than 0. No motion, net force is 0. And Newton's first law applies to this. So Newton's first law states that an item in motion stays in motion unless acted on by an external force. This also means that an item at rest stays at rest unless acted on by an external force. All right, 8, friction. So friction is a contact force, and this is between two objects, and this causes one object to slow down and often to stop. We just talked about net force. Net force is the extra force applied to an object that results in movement of an object in a specific direction. Remember that a force has both a direction and magnitude. So you will have to solve different problems determining the net force and determining if it's balanced versus unbalanced. Remember, you need both direction and magnitude. At the very beginning of this unit, we talked about inertia. Remember, inertia is a resistance to a force. So a great example of this happening in our everyday life is if you're in a car or the school bus and you're riding along, going along perfectly, you're sitting still, but say you have to slam on your parents slam on the brakes, so the bus driver slams on the brakes and your body goes flying forward. By you flying forward, that is a great example of inertia. You are resisting the stopping of the forward motion, and you continue to fly forward until you have applied force by running into the car seat or your seatbelt. All right, centripetal force is when an object moves in a circle, and as it's moving in a circle, it is being forced to the center of the circle. This is often seen and felt on a roller coaster. So there is a relationship between accelerating and unbalanced forces. So to accelerate, there must be an unbalanced force. Remember that a force has both direction and magnitude. So to accelerate, there's a change in either direction or speed. So Newton's second law talks about this a little bit, but Newton's second law is for force to occur, there must be mass and acceleration. And then Newton's third law is for every action, there is an equal and opposite reaction. So if a rocket is taking off into outer space, that you have a forward motion, but that means there has to be an opposite reaction. So you see flames and smoke coming out the backside when it is heading up into space. All right, so again, you have a test tomorrow. Some of the tests will be figuring out those unbalanced versus balanced problems that we've been working on. So for the remainder of class, please work on those in your ISN. Tomorrow you have a test on this. It is open notes, so you should do okay. So you get to use the notes that you take today and your notebook. Other than that, that's all I have. Please study, and I will see you later.